Welcome back to Concepts in Arithmetic. We are continuing to work with fractions here, and in this video we are going to look at word problems involving fractions. So let's just get right into the mix here and look at this example. Sam spent 3/4 of his money on an $18 book. How much did he have at first? So one thing that I think is helpful to do is to kind of interpret what we're being asked to find. Okay, so what we need to do is 18 is 3/4 of what? Okay, so that's the question we have to answer. The what, in this case, is going to be the total of the money that he had before. So 18 is 3/4 of what? Now, remember how we were interpreting multiplication with fractions. Basically, this is saying 18 equals 3/4 times blank. Okay, so to figure out what goes in the blank, we would divide by 3/4. Okay, now I would also like to note that we can make a nice teacher solution here where we do a bar diagram. Okay, so we're talking about 3/4. So I should break my bar up into 4 pieces. Okay, remember the denominator tells you the number of pieces to work with. Now the book costs $18, and that costs Sam 3/4 of his money. Okay, so over here we can see that 3 units in the bar diagram equals $18. Therefore, 1 unit equals 6, or 4 units equals 24. So we can write our sentence here. Sam had $24 to start with. And I would also note, right, remember what I mentioned, we have to take 18 and divide by 3/4, but of course we know that dividing by a fraction means inverting that fraction and multiplying. So 18 divided by 3 gives us the 6. Multiply by 4 gives you 24. Okay? So that computation is lurking in the background of what we have over here on the side. Okay? It is there even if it didn't look like we were writing it that way at the very beginning. All right, another example. Okay, suppose 4/7 of a group of children are boys. If there are 18 more boys than girls, how many children are there? Okay, so this is a 2-step problem. So 1, 2, 3, 4, 5, 6, 7. Okay, I've got a bar diagram. I broke it up into 7 pieces. And remember, the denominator of my fraction tells me how many pieces I should work with. Okay, so the problem tells me that 4/7 are boys. Okay, now it doesn't say there are 18 boys. It says there are 18 more boys than there are girls. So what I'm going to do is I'm going to redraw my diagram here. And I'm going to stack them up like this. Okay, so this is the segment representing the boys. I've got 4 pieces. This is the segment representing the girls. I've got 3 pieces. The problem tells me that is 18. Okay, so 1 unit equals 18 children. And my bar diagram has 7 units altogether. Okay, there's no need to find the boys and the girls separately. We can do it all in one shot. So 7 times 18, okay, 7 times 10 would be 70. 7 times 8 is 56. 70 plus 56 is looking like 126. Okay, so 1 unit equals 18. 7 units would be 7 times 18. And now we can write our sentence. There are 126 children. Okay. Another word problem. Julie used 4/7 of a bag of flour to make 6 cupcakes and 30 cookies. Okay, so in the first round of baking, she did 6 cupcakes, 30 cookies. With the rest of the flour, she made 18 cupcakes. How much of the flour did she use to make the cookies? Okay, now this is a little tricky here because in the first round she made some cupcakes and the cookies. So here's the way I would do this problem. Okay, so I start out with my bar diagram. As before, I'm going to break this up into 7 pieces. Because once again in this problem, the denominator in my fraction is a 7. Okay. 4/7, this was the cupcakes and the cookies. I'm going to focus on this part here. She said, with the rest of the flour, she made 18 cupcakes. So this was the initial baking, cookies and cupcakes. And then this is the remaining flour that's used to make 18 cupcakes. So that tells me that 3 units in this diagram is equivalent to 18 cupcakes. So that means each unit must account for 6 cupcakes. Okay, so that tells me over here, on this side, with the 6 cupcakes, she would have used 1/7 of the flour. Remember that first round of baking had 6 cupcakes, 30 cookies. And by our calculations here, each unit of the diagram corresponds to enough flour to make 6 cupcakes. So this is the amount of flour that got used to make the 6 cupcakes. That means the remainder in this part must have been used to make the cookies. So she used 3/7 of the flour to make the cookies. Okay, so once again, nice teacher solution. We have a bar diagram. We're showing the computation. We've got our 1 sentence for our answer. You will notice here, this is where I gave us an interpretation of the computation. And those are nice for these one-step word problems. Over here, I really only had to do one thing to solve it. I had to take 18 divided by 3/4. That one computation did the trick. In the next 2 problems, you'll notice I had 2 steps. Okay, so the interpretive question is less important in those situations. Okay, one last thing I want to discuss here, and that is creating word problems. Okay, so as teachers, we need to be able to come up with problems for our students to solve. And the problems that we come up with need to illustrate certain aspects of the computation that we want the students to learn. Okay, so here we're trying to make up a short word problem that would lead the student to do this computation. So we want to get the student to do 72 divided by 3/5. And we are using partitive division. Okay. Now remember, partitive is asking how big is the part. We know how many parts there are. The question is, how big are they? Okay. So I might look at something like this. Get my bar diagram here. Notice I did 5 pieces. As in the previous problem, the denominator you're working with tells you how many pieces you should have. Okay, now I'm going to take 3 of those pieces. And this is going to correspond to 72. Once again, it's very helpful to come up with an interpretation before we even start, okay? So we're thinking 72 is 3/5 of what? Because in mathematical symbols, that is equivalent to this times blank. Okay, so 3/5 times what gives me 72? Well, to get this value, I would divide by 3/5. Okay. And now once we've got this, once we understand this, we can come up with something really easy. In fact, we could mimic that very first example that we saw at the beginning of this video. We could say Travis spent $72 on, let me think of something that would cost approximately $72. Travis spent $72 on video games. I know they're not quite that expensive, so let's pretend he bought more than one. Okay, so he spent $72 on games. This was 3/5 of his money. How much did he start with? Okay, so starting here, $72 is 3/5 of what? So starting here, the student would be led to this interpretation, which leads to this diagram, which leads to doing 72 divided by 3/5. Okay? So when you're creating word problems, make sure you understand what interpretation of division you're looking for the students to use, and that can be illustrated in your diagram. Your diagram tells you the interpretation, and now that you've got the interpretation, you can come up with a realistic question for the students to tackle.